This problem requires the understanding of the impulse and the force, the relationship between the impulse and the force. So let me explain what this the problem is. You have a wall here. Let's say this is the wall. This is the wall. An object is moving towards the wall, and the velocity, the mass of this object is 0.2 kilogram, and the speed is, I'm just calling this speed as v1, which is 20 meter per second. With this velocity, this object is approaching towards the wall. Once it hits the wall, it is rebounded, it comes back, and the velocity of this object is, I'm calling this velocity v2, and this velocity is 12 meter per second. Okay? And what is asking, and this ball was in contact with this wall, and the time is given, the delta t, which is the time, is 60 millisecond. 60 millisecond. So if you need to change this millisecond to the second, you need to divide it by 1000. Then that gives you the second. So this is all the information here. An object has certain velocity and certain momentum, and it approaches towards the wall. Once it hits the wall, it rebounds back, and the velocity after hitting the wall is 12 meter per second. And remember, the direction of the velocity is opposite here. And you need to calculate what's the average force the ball exerts onto the wall. See, if I need to calculate the force, the only two things I need is what is the change in momentum, or what is the impulse, and what is the time. Okay, so first I'm going to use the conservation of, I'm going to find it out the change in the momentum of this object. So what is the change in the momentum? The change in momentum of this object. Change in momentum. Here, whenever I say momentum, it means the linear momentum. Change in momentum. This change in momentum, which is denoted by the delta P, is equal to the mv1 negative, because this is a change. This would be m times negative v2. And the reason this velocity is negative, because the velocity v1 and v2 are oppositely directed. The velocity is in positive x direction, and this velocity is in negative x direction. So the direction of the velocity v1 and v2 are opposite, and that's why we have put the negative sign here. So the change in momentum is simply given by m v1 plus v2. Now let's plug in all the numbers here. What is the mass? Mass is 0.2 kilogram. The velocity is 20. And the second velocity is 12. So once you plug in all the numbers, let me use my calculator just to plug in all the numbers here. This is 32 times 0.2 is 32 times 0.2, which is given by 6.4. So this change in momentum is 6.4, and it does have the unit as same as the momentum. What is the unit of momentum? Kilogram meter per second. So that's the change in the momentum. And now we need to calculate the force. The force it exerts onto the wall. So by Newton's second law of motion, the force is equal to the rate of change of momentum. Change in momentum divided by the time, which is equal to change momentum divided by the time. We already have calculated the momentum right here, which is 6.4. What is the time? The time is given, which is 60 milliseconds. So I'm just putting the 60 millisecond here. The 60 divided by 1000. So once you plug in all the numbers, let me plug in the numbers for you. Into 1000 divided by 60. And this is given, it's close to 106.7 Newton. So that's the average force. So one thing, so if this ball exerts a force onto the wall also exerts a force onto the ball, and that's why the ball keeps moving in the opposite direction. And this wall also moves because the momentum is always conserved. But the change in momentum of this wall, because the mass is so heavy, the velocity will be very, very, very small. So this wall hardly moves, and the reason is the mass of the wall is enormous, and you will see a very tiny change in the velocity. But the amount of force the ball puts onto the wall is the same as the wall puts the force onto the ball. This has to be exactly equal.